Separation of solid-solid mixtures. We have already learned the various methods of separating solid-solid mixtures such as picking and winnowing. The choice of each method depends on the size of the particles in the mixtures. Size is a physical property. The method chosen to separate a given mixture depends on the physical properties of the components of the mixture. There are other methods of separating solid-solid mixtures. We shall learn these other methods by observing several experiments. Experiment. Separating a mixture of iron filings and sulfur. Let's observe this experiment to understand how iron filings and sulfur can be separated. In this experiment, a mixture of iron filings and sulfur is placed on a white sheet of paper and spread out. A magnet is placed above the mixture and the observations noted. The mixture provided is grey-yellow in color. When a magnet is held above the mixture, the grey particles are attracted, leaving a yellow powder on the paper. The grey substance attracted by the magnet is iron, and the yellow substance left on the paper is sulfur. A mixture of iron and sulfur can be separated by use of a magnet, because iron is magnetic whereas sulfur is not. This method is applied in industries such as iron recycling, glass recycling, and flour mills to remove iron particles. Experiment. Separating a mixture of sodium chloride and iodine. Let's observe this experiment to understand how a mixture of sodium chloride and iodine can be separated. In this experiment, a mixture of sodium chloride and iodine is put in a beaker and covered with a watch glass containing cold water. The mixture contains white and shiny black crystals. The beaker is heated gently until there is no further change. As the beaker is heated, a purple vapor is observed. On cooling, the purple vapor forms shiny black crystals on the surface on the watch glass. White crystals remain in the beaker. The shiny black crystals are iodine crystals, whereas the white crystals are sodium chloride. When solid iodine is heated, it changes directly into vapor, the purple vapor seen. The vapor cools to form solid iodine on the cold watch glass. The process where substances change from solid to vapor directly is known as sublimation, while the change from vapor directly to solid is known as deposition. The solid formed when the vapor cools is known as sublimate. It is possible to separate the mixture of iodine and sodium chloride because iodine sublimes while sodium chloride does not. Other substances that sublime are anhydrous iron 3 chloride, aluminium chloride, benzoic acid, and solid carbon 4 oxide, dry ice. The process of sublimation is applied in various processes. For instance, dry ice is used in cold boxes by ice cream vendors. Dry ice is preferred over ordinary ice because it sublimes, leaving no wetness. It is also a better coolant compared to ordinary ice. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.